Well, I'd like to welcome everyone to the beginner session. And tonight's presenter is our very own Jay Anderson. And he's going to tell us all about an astronomy bucket list. Over to you, Jay.
Very well. Okay, bucket list. Something to do before you die. When you're closer to dying than I am, then your bucket list is going to be short. And if you're old as I am, then you haven't got very much left if you've done it right. And if you're young, boy, have you ever got a lot of things you can do. So what I'm going to show you is a list. And a lot of it is the list that I had at the start. And a lot of it's been done, but I think it'll give you some ideas. And you just might want to make one up for yourself. So what do we start with here? Why would you do it? Well, something to plan for. Keeps you focused, especially in this area of the pandemics. And when you've done them, you can brag about them. And if it's too cold or something like that, well, it says, hey, this is the only time I'm going to be able to do this. So I'll go out and try it. I remember watching an asteroid occultation at -32 in a wind one night. Unfortunately, I was not under the shadow. So I just watched the two of them pass by. So I've made a list with bronze, silver, and gold objectives. And the bronze ones are the ones that you'll fall into for the most part if you don't go searching them out. And silver means you might have to go after them a little bit. And that might mean going out in the cold conditions or traveling outside of the city to see them, or it might be traveling somewhere else in the world to see them. The gold objectives are things that you may have to go a long way to see, but are also relatively rare or require a bit more work. And the second statement I made there is very true, because for some of these things, it'll be very easy for you if, for instance, you make a trip to the Southern Hemisphere for no particular reason other than to have a bit of a holiday. But mostly they require a little bit of effort and planning, because they're more than just wandering out with a telescope and pointing it at whatever planet happens to be up in the sky at that point. So here we start with a bronze list. This is not very difficult. So go and see all 5 of the brightest planets at one time. Well, as it turns out, June 20th this year, right in here at 4:45 in the morning, you'll be able to do that, because here they are all strung out across the sky. And the limiting circumstance on this one is Mercury, because Mercury doesn't stay visible for all that long a time. The rest of them are pretty slow moving. They're going to be there for quite some time. So you're basically going out to see Mercury while all the rest of these guys are up in the sky. And if you have a telescope, you can see all 8/7, depending on what you think of Pluto. Well, they're going to have a pretty big telescope to take a look at Pluto. How about going out and seeing the zodiacal light? Well, anytime this spring, you can go out in the evening. You just have to go and find yourself a very dark spot. And I'm not sure, but I'm not sure if that tree is one of the ones out at Birds Hill Park or not. Probably not. It looks like it's not quite dark enough at Birds Hill Park. But just go out and see the zodiacal light. If you want, you can take a camera, but this bucket list I'm going to give you requires nothing other than looking at it visually. You might want to see how well you can identify constellations. You know, for years I looked at things in the skies, but I never really knew what the constellations are. I can certainly identify a dozen. I think most of you could. All of them, many of them on the zodiac, but if 12 is too little for you, make 24 your goal. So you can wander out and look up at the sky and say, oh yeah, Leo's out tonight, and oh yeah, here we are with Libra coming up, and so on and so forth. And I put the names of the zodiac constellations in there for you, and you can add 1 or 2 others that sneak in little bits if you really want to be precise about it. But really, to do that kind of a job, you'd have to go out just twice in the year, in spring and in the fall, or the summer and the winter, and identify the constellations that are up. you really want to challenge, though, try doing it in the southern hemisphere where you haven't had to look at them every night. You went out into the sky where half of the constellations in the sky are something that you've never seen before. And of course, everything you are familiar with is upside down. Here's another 3 little goals for you. These ones, M31, the Andromeda Galaxy. Most of us who've been out at a star party and in a dark sky, and especially in the fall, or have been able to see the Andromeda Galaxy by eye. But how about M33 by eye? M33 is pretty easy to find. Here's M31, the Andromeda Galaxy, and we have the nice little pointer star and the second star here, and it's an equal distance up above it, but just about the same distance down and below is M33. That should be pretty easy with binoculars, but in exceptionally dark skies, some people have seen it by eye. And if you wanted to try that, that would be a real challenge by eye. But certainly you wouldn't want to confine yourself to just one of the members of our little galactic cluster. Why not pick up one of the other bright companions that are in there as well? As far as finding the name of the 10 brightest stars, well, I've listed a bunch of them down the side there. And I've crossed off 4 of them because those are southern hemisphere stars that you wouldn't be expected to see from Winnipeg. But you should be able to identify all of these stars and kind of treat them as friends in the sky a little bit. Vega is interesting because Vega is exactly at 0 magnitude. So if you want to compare brightnesses above and below 0, Vega is your star, so to speak. The rest of them, you probably encountered them at one time or another. But you should know them well enough that on a cloudy day where 1 or 2 stars are peeking out from between the clouds, that you can say, oh, there's Rigel tonight. Oh, there's Betelgeuse tonight. Just because it is a friendly little face, quote unquote, up there in the sky. How about watching the lunar eclipse? Well, this is a no-brainer because we have 2 lunar eclipses this year, but you should watch a lunar eclipse. And if it's cloudy, you might want to travel to where you can find some clear skies on the night of those eclipses. So here they are for you. One is in May and the other one is November. Neither one is a terribly challenging month, although May it could probably be a little easier to find comfortable temperatures. And they're both visible. The maps up here show that in the case of the May one, we are on the edge of seeing it at moonrise. And then we go into the November one. We're also well placed for things. This between P and U is when it's in the penumbral phases here. So those are not going to be a problem for us because very likely you won't recognize a penumbral phase unless you're pretty careful about watching the intensity change. It's not until the moon gets pretty close to becoming partial that you begin to notice the darkening on one side of it. Penumbral phases out in here, which is happening just at the moonrise, would probably not be noticeable at that low an altitude. How about taking a look at Venus in the daytime? You know, it's really pretty easy to do. The hard part is knowing where to look. And so the way to handle that is watch it before the sky gets too light to see where it is, and then try and follow it as the sun comes up. I know I used to, when I worked downtown and taking the bus home in the mornings, I would see if I could spot Venus just from inside the bus, knowing approximately where it was. But like all tiny little bright things in the sky, it's hard to get your eye to focus on it until you actually see that bright spot. A horizontal Milky Way, this is something that would Judy and Sheila wanted to see, a Milky Way that's horizontal. Well, it's not too much of a challenge. Here's a horizontal Milky Way. You go out at 1 a.m. on April the 9th and look north, that's when you'll see a horizontal Milky Way. If you want to photograph it, that's another thing, because it takes a pretty transparent sky to be able to photograph something that low. But of course, the goal of this bucket list is not to photograph, but to just watch things. And just to sort of give a boost to the mother organization, I think that if you wanted to complete one of the bronze goals, you should obtain the RASC's Explore the Universe certificate, which covers more in-depth things than this over a broader set of categories. So start thinking about what you might put down as a bronze goal that you haven't already done, or that you really didn't take a lot of look at. And we'll go on to some silver challenges. How about watching a stellar occultation by the moon? Well, you know, they're interesting events, particularly if you could do it with a bright star. And the thing is, they're so common that you could go out on almost any night when the moon's out and find a star that is going to pass in front of it. This one on March 18 at 11:03 is a fairly bright star, Gamma Virginis, and magnitude 2.8, and reasonably high in the sky, and it shouldn't be too hard to find the moon since almost full. And just watch that star disappear behind the moon. See if it's a star that has a close companion, it might not drop instantly in brightness, but actually might fall a little bit in stages very quickly, indicating that it's a multiple star. You can look that up ahead of time just to see what you might expect, or you can just go out that night a few minutes ahead of time and point binoculars up, or just by eye. Although bright moon and a star, even at 2.8 magnitude, they tend to blend into each other a little bit. How about watching a variable star? Well, Algol, which is in Perseus, is a pretty easy star to find and a pretty easy star to watch. It has a period of just under 3 days when the brightness drops, and the brightness drops about a magnitude, so it's quite noticeable. Even better, the deep part you see here takes only about 10 hours, and the front part of it would take only 5 hours. So in a 4 to 5 hour period, you should be able to watch that star's brightness drop quickly or steadily before it begins to recover. And again, you could probably do something photographically and measure it, but no, our goal here is just to do things by eye. And notice that Sky and Telescope publishes the times and dates of the minima in each month. And so it's a relatively easy job to plan when you might want to go out and have a look at it. Even go out to Spruce Woods and try it if it happens to be the right night or out there. Here it is, a photograph showing it at its maximum minimum, and you can use the 2 stars here on either side of it to measure or at least monitor how its brightness is changing. How about watching a planet go across the sun? Now, this is a challenge, but it's a challenge because you're not going to be able to do that until 2032, and you can do it again in 2039. You won't ever see the one that's on the left there because that's a transit of Venus. But this one with this little guy here is a transit of Mercury. And so these are the dates that will come along. You'll have to leave Winnipeg because neither one of them is visible here. But the fortunate thing is they occur in the daylight. So if you get to your destination, it won't be any trouble finding where to look. How about watching Saturn's rings disappear? Now, that was a bit of a challenge we had the last time that happened, which was back in, 2009, I think it was, yes. And so we're going to be able to do it again in 2025, except that Saturn is so close to the sun at the time. Now you say, okay, well, I'll wait till 2 weeks later and watch it. Well, when Saturn's rings are edge on, it's really only a 1-day thing. So if you're going to watch it, you're into March 28th, 2040. So make sure you're young enough to make it till that date. There'll be 3 events actually, because Saturn is in retrograde at the time, so it zigzags back and forth across the sky. How about watching a solar flare? Well, we have a PST that we loan out in the club, and solar flares, when they happen, are reasonably easy to see, but it is also possible, although rare, to see it in a white light telescope. The thing to do is, when people send you a note saying there's a flare on the sun because somebody's watching it with an H-alpha telescope, see if you can get out quickly and take a look in white light, or use an H-alpha telescope if you've got one. They're quite interesting. The ones I've seen, the one I've seen was about a 35-minute process, so it was possible to show it around a bit. How about a supernova? Well, you have to wait for one, but you can also look in another galaxy, but that requires a telescope. A supernova 1987A, discovered by a Winnipeg member. It was visible in the southern hemisphere. Here it is here. And that was quite interesting, quite reddish when I saw it in a trip down at the southern hemisphere. 1975, I discovered Nova Cygni one day when I walked out to my mother's house in the Okanagan. Unfortunately, 10 or 12,000 other people also discovered it that night, because as you can see, it was almost as bright as Deneb in Cygnus, and so it threw the constellation Cygnus right out of whack. There, it didn't make sense as the Swan anymore. We could watch the moon occulta planet. Well, here's the one I took in 2009. Here's the moon and Venus, and here they are right here. Just about to be occulted. You'll see that it's in the daytime sky, so you can't, if Venus is the target, it's really not a problem if it happens to be in the daytime, as long as you can find them. This takes me back to your bronze goal of seeing Venus in the daytime, or finding a very thin crescent moon in this case. If you're lucky, it's a fatter moon. Well, okay, how difficult is that going to be? Well, it isn't actually. December 8th this year at 9 in the evening, the moon is going to occult Mars, and here I've taken a little diagram of it from Starry Night. If you want to be a little quicker, on October 12th, the moon will occult Uranus, so you'll need a telescope for that, or at least binoculars. How about seeing a really early moon? This is one of Stan's favorites, and if you want to get some details about how to do it, this picture that I show you here with the moon, that moon is 30 hours old, so it's still got a 6 hour to go if I want to achieve this goal. You can see some of the records in here if you think you really want to challenge, and it's been photographed right at the instant of new moon. Or you can go watch a total solar eclipse, and in that case, you see the moon right at new moon. How about watching an annular and a total eclipse by not the partial parts of them, but right in what we call the central parts of the eclipse? Well, that's a pretty easy task to do. You just have to be there, and so it gets a silver because you do have to be there. But it's going to be a pretty cheap silver because there's one of each of these coming up this year. And so you need to travel down into, say, around the Four Corners to see an annular, and you can pick where you want to go to try and see the total eclipse. So it'll be probably the easiest in quite a few number of years to see an annular and a total eclipse and put it on your silver list this year. Now we go to the gold stuff. How about a grazing occultation of the moon? A grazing occultation is when a star is right on the limb of the moon. And as the moon passes by, the star blinks on and off as the mountains on the edge of the moon move across that star. It requires quite a bit of planning. It requires that you be in the right spot. But here's a diagram. These are actually in the Observer's Handbook. And say number 56, the grazing edge is right here. So you could travel a little bit north up just into the Interlake, right on the line. You can get higher resolution maps as the times come. In this event, March 11 at 3 in the morning, I picked a rather bright star at 4.8 magnitude, so it'd be easy to watch it with a telescope. I think binoculars, you might see it, but it would be a bit of a challenge because you really want the magnification to separate it from the bright moon as much as possible. There's all kinds of other choices, and this is only for February, April time period. So there's probably a dozen times during a year when you could go and do that. And they're really neat to watch. If you want to get fancy, you can record them and contribute to the science. But the reason we do it is because when these stars blink out, it tells you what the shape of the mountains is on the edge of the moon. And here is an example. This red line is the predicted shape of the moon's mountains. But if you look at these traces from people who are watching, you see these ones blinked out here, came on briefly here, came on again in here, came on through here. These are all supposed to be not visible. So obviously the shape of this limb of the moon needs a little bit of modification. This is somewhat older edge of the moon here. It comes from Watt's profile. Nowadays we have better predictions of the edge based on some Japanese satellite measurements. Another thing we might want to do is watch an asteroid occultation. Let's see if I can switch this off, get this going. Now, an asteroid occultation is a lot more challenging than a grazing occultation because the paths are much narrower and the targets are a little harder to find. So what I'm going to show you, these 4 pictures are actually this star being blinked out by the, and so we'll just move that forward a little bit. And we're going after a 2.7 magnitude star. You can watch that. Now, this star is not completely blanked out by the asteroid. It has a little bit left behind, suggesting that it's either a multiple, there we go, and coming back up again, came up a little more quickly than it went under. And when you look at the, I know they've got it here somewhere. Here's the star chart for it. Oh, gotta go back a bit here. Here's what it looks like as a curve. You can see that it came down fairly slowly. Let me put my laser pointer back on, comes down slowly, flattens out a bit, but never gets down completely to 0 and then comes back more quickly. Tells you something quite distinctive about the shape of the asteroid when you do that. A little more of a challenge, watch a planet occult a star, and this one's going to be a challenge. We have Venus that's occulting a star, and it's not a very bright one, also in a daylight sky. So you probably have to wait till 2044 when it occults Regulus. Be really worth watching because Regulus should be visible in the daylight. Sun will be getting down a bit at 4 p.m. And I actually saw one of those back in 1976 when Mars went in front of Epsilon Gemini. This is a picture I took about 30 minutes after the event. I watched it visually. There's nothing. In the days of film, you couldn't really photograph it, except you get a picture of Mars with no star in the field. But it was an interesting event. And how about going into the southern skies? If you happen to go there just as a matter of course, then this is not a gold challenge for you, but you might want to make a special point if the opportunity arises to go and see the Magellanic Clouds or to see the magnificent Milky Way and its star clouds and its dust clouds from the southern hemisphere. And this is my last bucket list. This is something I've been wanting to do for a long, long time. I watched an annular eclipse at sunrise in 2015, but this last December, got to watch a solar eclipse at sunrise. And so that was a major bucket list goal for me. So it took me 75 years to get as many of these things done. And there's some things I haven't done, like do the watching Algol go through its paces. And I haven't had, well, I've had one successful asteroid occultation, but I think I'd like to watch another one. So whatever you're thinking about doing, put it down on the list and get about doing it. And I think you'll find that by the time you reach my age, if you're not already past it, that you'll be able to look back and think, yeah, there's some pretty interesting things we saw along the way. Oh, thank you very much.
Thanks, Jay. So there we are. Thank you very much. Jay Anderson went through the astronomy bucket list for us, certainly giving us things that we can look forward to. We'll now move into our normal meeting and I'd like to welcome everybody who's here. So tonight, as we said, Jay just finished the beginner session. I'm going to talk a little bit, do some announcements, talk about some volunteer positions we have available. Brian Stach will be doing our What's Up. Dr. Michelle Boyce doing What's New. We'll have a 10-minute break. And then our main presentation today will be by Gord Tulloch, Boots on Mars. And then a virtual get-together afterwards. So as far as announcements go, Judy Anderson is working with a committee of council and members to just review the bylaws, and as was asked of us at the last AGM. The St. Malo Spring event has been canceled. We'll try again next year. Again, as I mentioned, we'll have a breakout room tonight just to visit, socialize. We do plan to do a Mars geology field trip this summer. One of our presenters offered to take us out where they take astronauts and do a little bit of research. So that would be pretty cool. Maybe look at some actual asteroids or holes from where we've had some impact craters. We are looking for volunteers who would like to do a presentation at the meeting. Now we have our traditional format, but we look forward to having people who may want to bring in storytelling or any other aspects to give a different slant to astronomy and make it more interesting for our members. Our Lonoscope coordinator, just a reminder, is Mike Caracas. If you want to borrow anything, the beauty is that it appears that the COVID rules are now loosened quite a bit significantly starting next week. So getting together and going out is going to hopefully start happening more often, especially once it stops snowing and the weather gets a little warmer. I just want to remind people that we have a binocular interest group that Darren Henning runs. If you want information on that, please go to the forum, the website in the member section forum. Darren posts at least 3 times a week about different things that you can be looking at. And again, as now that things are loosening up, he'll probably be setting up and having get-togethers to go out and find out how best to use your binoculars and see the night sky. Policy and Procedures Manual, Mike Stevens and Mike Caracas are working on that as well with some other volunteers from the council. The strategic plan, which is what the council will be starting to work towards, is on the website. The thing I'd just like to let people know about the strategic plan, this was done in consultation with the membership. The idea of the strategic plan is that if we get members who volunteer to take on part of that strategic plan, then that part will be developed and supported by council. If no volunteers come forward, then those parts of the strategic plan will not be action on. It's not meant for the council to do everything, but to be facilitators for the membership to make the things they want to see happen. Appointments at the council meeting on Monday. We appointed these positions. There are still some positions to be filled, but our finance committee chair is Mark Irvine. National Council representatives are Brian Stach and myself. Sprucewood Star Party chair is Sylvia Graca. Binocular Interest Group is Darren Hennig, as I mentioned. Our newsletter editor is Gord Tulloch. Membership coordinator Abdul Amani. Lonoscope program Mike Caracas. And our meeting coordinator is Judy Anderson. Volunteer opportunities. Now I know there's all kinds of you out there wondering, what can I possibly do to help bring astronomy to everyone else? Well, here's some different roles that we've got for you. We have a meeting coordinator. The meeting coordinator really just confirms that the presenters are available for the meeting, and we'll do the follow-ups to make sure that our guest speakers do get a little thank you gift from the RASC Winnipeg. Volunteer coordinator is just that, exactly what it says. We are looking for somebody to be the spring star party chair, so that we can hopefully have 2 star parties in a year. Explore the universe coordinator. That's a person who takes anybody who's completed the basic Explore the Universe certificate. They will review it, and if they've completed all the things, they'll coordinate with national and then work towards the award, and then coordinate any of the additional observing certificates with national. We are looking for a webmaster, so if you're good at IT and like to do that kind of thing, please contact us. We'll let you know and put you in place with members of the council who will help get you started on that. Mentor coordinator, last year we started off the mentor program, and the mentor coordinator just simply maintains a list of experienced RASC volunteers who would like to help others when they want something or want to learn something specific, and that person puts those 2 people together, or a group of people perhaps. Mentioned already about meeting presenters. Finance committee, if you have an interest in finance, let us know. Observatory committee, in particular, we're looking for volunteers to train new members on the dome and etc. So you may not be interested in doing all the stuff when we do reviews and what we're going to do with the Glen Lee, but you may say, hey, I do know how to run the dome. I do know how I'm comfortable showing people around and how to get into the warm room and how everything works out that. We would really love to see you that. Public outreach, as I said, looks like things are hopefully going back to some normal. I've certainly seen the release, and outdoor activities is pretty much wide open with no restrictions. So if we choose to start doing public outreach, we'll be able to now, and it'd be nice to have a coordinator to do that, simply to make sure we have enough volunteers when an event is planned. And as I mentioned earlier, talked a little bit about it, the Explore the Universe coordinator. Our members observing night tomorrow night, I've arbitrarily canceled it because in all likelihood it is very much drifted in, and since we had the storm today, we're not so sure that the U of M would open up, and it's also supposed to be a little chilly. So keep tuned, posted, and hopefully next month it'll be nicer and we'll be able to have an actual members observing night. Now, before I go on, does anybody have any questions? If you do, you can also put it in the chat and I can answer you individually if you like. Okay. I'd like to introduce our next speaker then. Our next speaker is Bryan Stach, who will be doing the What's Up. Please welcome Bryan Stach, and I will stop sharing so that Bryan can now start sharing. Over to you, Bryan.
Thanks, Dennis. Okay, so we'll talk about what's up for February 22nd. This month here, we have some few things lined up for you. So let's see what's up for February. All right. So let's first talk about a little bit about the planets. Unfortunately, most of the planets, it's only going to be in the pre-dawn morning only. Mercury, Venus, and Mars being the 3. And I'll show you exactly what's going to happen on February the 13th. Venus is supposed to be super bright. It's going to max out on the 12th, apparently, with a magnitude of -4.9. Mars will be mostly in Sagittarius in February, but Mars will slowly take over Venus throughout the month. It will just start to rise a little bit more. Unfortunately, Jupiter is getting closer to the sun, so it's going to be increasingly difficult in seeing it. And of course, Saturn is actually behind the sun right now, so it's going to be emerging from the sun very soon. All right, so wrong space bar. Okay, so what's up for February? Of course, we got the first quarter in February the 8th. We do have Venus that's 7 degrees north of Mars. I'll show you more about that later. Of course, we do have the full moon on the 16th. We do have the zodiacal lights that will last for roughly 2 weeks, starting February the 18th. But we do have the full moon on the 16th, so it's not going to interfere with it because the moon won't start to rise around 8:18. So the zodiacal lights are going to be visible well before the full moon starts to rise. And of course, the last quarter of the moon would be on the February the 23rd, and Mars would be 4 degrees of the moon on the 27th, which I'll show you guys later. Okay, so on the 12th, I did say Venus is going to max out in terms of brightness at minus 4.9. So, but of course, like I mentioned, Mercury, Venus, and Mars is going to just be a morning planets for your viewing. It's going to be lasting for about a week or so. So it'd be interesting to see how bright Venus is going to turn out. On the 13th, as I mentioned, Venus would be 7 degrees north of Mars. So you can kind of like see it's not going to really change much for the next month or so. Venus and Mars will slowly creep up towards Venus throughout the month, but it won't get really that close to it. Now, I kind of discovered this accidentally when I was looking at the model here. On February 27, like we mentioned about Venus and Mars, we do have the crescent moon on the 27th, but you can see it's pretty low in the sky and it's already starting to get pretty bright in the morning sky. I do have it listed at 6:42 a.m. So that'll be interesting to see. For the winter constellation, Orion will start to rise apparently around 3 p.m. It's going to set around 2:15 a.m. So if you're interested to Bryan, like me, you have to get out there pretty soon. But for the Milky Way, unfortunately, there's no Milky Way overhead, so you won't be able to see the Milky Way this month. So I'll talk about a little bit about the zodiacal lights. If you haven't seen it, if you are new, they're just maybe a little bit brighter than the Milky Way if you've seen the Milky Way before here. But it's larger than you think. And I'll show you a picture of what I mean, because like when I first saw it in Arizona, it took me a while to actually kind of see it. It's bigger than what you think. It's more of a triangular type shape of a luminosity. But unfortunately, if there's moonlight or haze or light pollution nearby, it has to be a pretty dark sight. And I'm pretty sure Glenn Lee would be able to support that. As I mentioned before, the moon will start to rise about 8:18 p.m. on February 18th. So the lights will happen well before then, so it shouldn't interfere. So make sure you try to see it out there. It's a good opportunity to see it because it's just right after sunset. The next time you're going to see it, which would be in the fall, it'll be in the morning. So probably now would be a good time to see it. So here's a picture of it. This was shot in Arizona. We were at nice dark sky. So as you can see, it's kind of a pyramid. This center line right here, I don't know if you see my mouse here, that's the path of the sun. So as you can see, this is a nice little pyramid here, and it's pretty bright, but it'll take a while for you to get accustomed to it. I am going to talk about a little bit more about the sunspots, the cycles. As you can see here on the top graph here, you can see it starts around year 1750. You can see it peaks. And it's roughly, the cycles are every 10 to 13 years, on average 11. So we're in a cycle right now, cycle 25. So what I'm going to do is, on my next slide, I'll blow it up a little bit. So you can see we're in cycle 25 right now, started around early 2020. Now, I got this from the Observer Handbook when I was reading this. So there's two sets of modeling they have, two sets of data to predict how many sunspots it's going to occur for the next 10 years or so. So I don't know why they have two modeling, but according to the Observer Handbook, and that's where I get it. So they have 100 years of data shows it's going to be a weak cycle during the cycle on the 25th cycle, or based on another set of data, 60 years of it, it's going to be a strong cycle. So what should we do? Well, just keep watching. So definitely the solar cycles, or the aurora, some of us would like to think about it, it's definitely going to be on the rise. Now, what about the weather? Well, unfortunately, I'm not really happy with this, and I know a lot of you won't be. As you can tell here, it's still going to be pretty cold during the nights. You can see here, one night's going to be well below 40. This is Sunday, this is coming up Sunday. And then every evening, it's going to be well within the 30s, minus 30s, unfortunately. Next Friday, apparently, it's going to creep up. almost to near zero, which looks pretty good. But I think it's going to be cloudy on those nights. Now let's see what we have in terms of clouds and precipitation. Looks like we're still forecasting some more snow. This bottom graph here, as you can see, we do have some clear nights. Tonight's supposed to be a little bit clear. Maybe early Saturday evening, as you can see here, but we do have a definitely clear night. Wednesday night, looks like most of the night it's going to be quite clear, but it's going to be quite cold. And the next reasonably clear night is going to be Saturday. So, hey, keep your eyes out open. Hopefully we'll get some clear nights and get some observing done or some viewing. But basically, this is how I'm thinking I'm going to do my observing. That's going to be it. That's going to be my observing. Just more snow. All right, everyone, take care. Thank you very much. Over to you, Dennis.
Thank you very much, Brian. So Brian's been talking about, well, actually a few times it's come up for those that are on that may not be familiar with it. This is the Observer's Handbook. And if you remember, you should have your Observer's Handbook by now, hopefully. If you're not a member, it is available for purchase from the Royal Astronomical Society of Canada. And the other book you may want to look at is the 2022 Night Sky Almanac. And again, this gives you a breakdown of all the things happening each month. So just not sure what we've got up there, but just gives you an idea and just shows you the different things. So that's what we have. Now, we actually had Graham, who's on tonight, was kind enough to donate those two books, as well as the Explore the Universe book, which we will be using and sharing out with other members of the club, anybody that's new that may not have their things yet. So thank you to Graham for being kind enough to donate those to us. So our next speaker tonight is Dr. Michelle Boyce, and she will be talking about what's new. So over to you, Michelle.
Okay, so actually, well, it's still topical, but this was put together last month, and I just finished adding some more slides. And this is on the James Webb Telescope. I actually took a deep dive into this thing. I was curious about many aspects of it. So I'm just going to share some elements that I've researched, although I've researched quite a bit more. Okay, so first of all, I was wondering, why was it called James Webb? And apparently it was named after a NASA administrator who was in charge of the first moon landing, and his pre-career before that was an attorney and an administrator. And his vision was a balanced space program. So he did human space flight and science. So it's named after this guy. Now, can I hide that? Yeah. So actually, I'm trying something new here. I got 3 monitors. I now have it down to my 1 laptop, so hopefully it will not crash. So this is a comparison between the James Webb Telescope and the Hubble Space Telescope. And I've even given here the F ratios, the arc second resolutions for all those astronomy buffs that like all the details, and its mass. I believe that even the power, oh yes, the price tag. Reason Hubble cost, well, we know it needed corrector glasses, so it went way over budget. So has the James Webb, but you can compare and they're kind of similar. I think what's important to note is the scale here, the person standing there, because I was going through the instruments and then I saw another person next to the instrument and I went, wow, it's actually pretty big. Okay, so here's a electromagnetic spectrum. And this is our visible spectrum. And you can see that the Hubble Space Telescope was in the visible to ultraviolet and it just into the infrared. The James Webb Telescope goes right into the infrared. Why is that? Well, actually, I'm going to skip this slide for a second. We can see here, this is the basically, actually, I need that slide. Sorry. I've had this slide up before, and basically, this is a balloon which represents the Big Bang type cosmology. And I'm just seeing, can you see my gestures? Yes, okay. So you imagine the surface of a balloon and you can draw little galaxy pictures on it. If you blow it up, you'll notice that they separate, and the further away they are from another reference frame, they move faster. So the light gets stretched. And what that means is the electromagnetic spectrum that we would know, say, of our sun or something from the Earth, which is relatively at rest with us, gets shifted more and more into the red. So what that means is as you look further and further back in time, because it takes time for light to get to us, the wavelengths have shifted into the infrared. So the Hubble Space Telescope can't really see that far into the past. Okay, and this is just our sun's spectrum here, some magnesium and hydrogen lines and so forth. So this is the Hubble deep field, and this is the Hubble ultra deep field. And it really cannot see beyond here because now the wavelengths have shifted into the infrared. So James Webb will be able to go back and look at the first galaxies, the first star formations. So it's digging deeper into the history of our universe. So that's another thing. It kind of complements Hubble, if you think of it that way. Okay, now these are Hubble telescope images, but this is in the optical and this is the infrared, the same structure. And this is a star factory. And in the infrared, you can see infrared tends to pass through dust. And James Webb, because it goes further into the infrared, will even be able to see more detail in terms of nebulosity. So it's not just looking at the early universe, it's looking at other things. So here's an idea for exoplanet atmosphere. So normally you look at the light spectrum coming from a star, and then when a planet passes through a star, you get the spectrum, which includes the star, but absorption lines for the planet. Wavelengths of light that have been absorbed by the chemicals. You take the difference between these two spectrums, and then you just get what's left over for the planet. And then you can look at these spectrums and look for indications of light, such as what's popping up here, water, and is it nitrogen? Methane, good old methane. Okay, so that's the idea also with James Webb. This is just a layout of the James Webb Space Telescope, and I've looked at some of the instrumentation here. What's interesting is this little flap here. I was like, what on earth is that for? It's a momentum flap, and basically, because of the way it's designed, the sun hits it and it causes it to rotate. So this is like a rudder that avoids the counter rotation. And then we have the heat shield down here, the telescope on the other side. And this just shows the deployment. I really love looking at this thing. It's a pretty cool animation. So there goes the little solar panel, and that's all it has for its power plant. However, that's sufficient. There's a little gain antenna. In fact, when you saw it launch, you saw this open. They saw this actual image of this as the booster disappeared with its cameras. And it's amazing because there's over 230 operations just to unfurl everything. And it is actually quite surprising that it's succeeded so far. And now it's in the process of aligning these mirrors. So it has very tiny micro actuators and it's trying to align the optics. And it's also cooling to the appropriate operating temperature, because for infrared, your sensors, your scope has to be cold. There can't be any heat around it. Otherwise, you'll get stray information while you're trying to look out deep into the universe. So I just find this quite amazing animation to watch. It's almost over. And it was being progressed on NASA TV, and there's a little website where you can watch the progress. Unfortunately, NASA website now is having a bunch of missing GIFs and images. I don't know what happened there. So I suspect they moved things around. I doubt someone hacked it, but who knows? So yeah, the mirror deployment and then alignment. So James Webb, this is a nice diagram. It shows that it keeps the hot side hot and the cool side cool. I don't know if anyone remembers that commercial from McDonald's quote, but you can see on this side here, it's 85 degrees Celsius, almost enough to cook an egg or whatever. And then on this side, it's super cold. Okay, so And there's like 3 layers of mylar material that's acting as a heat shield. And here's your solar panel getting the full blast of the sun. I don't know why that happened. I don't want to be here. I can get past this slide. Okay. Now, the other thing I looked at was the L2. This is a common question was asked about Lagrange points. And it's really a dynamical thing. The easiest one to imagine, and in fact, this is the wrong diagram, my apologies. That should be the Earth, that should be the moon. Regardless, it's just, yeah, this is a really bad diagram. Anyway, no, that's correct, sorry. The Artemis uses the Earth-Moon system Lagrange point. My apologies. So this one's kind of easy to imagine. It's a stable point between the Earth and the moon where the gravity balances. And this one is also kind of, you can kind of imagine. And these ones are really due to the dynamical rotation of the entire system. And you can look at that in terms of a potential well. So this is like a gravity well that's really deep for the sun, and there's a local gravity well here for the Earth. And this sort of shows the diagram. These points here are metastable. They're huge islands of stability. And if you know, Jupiter has asteroids following and trailing it called the Trojans. They hang out in these pockets in the Jupiter Sun Lagrange system. And here, this is slightly metastable. So in this direction, objects tend to drift into the Lagrange point, but there's a slippery slope on this side and this side, so they could easily fall out of the Lagrange point. So the James Webb Telescope requires some minor station keeping every 31 days adjustment. Now, this is what's really cool coming up. I just looked at this and I was trying to wrap my head around it, and I started reading papers on it. This is the orbit as it goes around. First off, it's called a halo orbit. Secondly, the solar panel on the back is always pointing towards the sun. The James Webb telescope is always pointing away from the sun. And it's interesting that it's like this, and the best explanation I can come up with is a cowboy holding a lasso and kind of twirling it, yet there's a tension. So there's a tension in the system holding James Webb out there, but it's spinning around this point. And in fact, this is what's called a Lysager figure. You can have figure 8 orbits and fancy orbits, and there are other spacecraft that have used this technique, so it's kind of cool. But the first time I saw it, I was just like, what the heck? And the reason it's in a halo is because that way the Earth doesn't block it. It's always got sunlight, okay? So this is a little of the onboard system I looked at. The telescope is a Korsch type telescope. Now, what's interesting about this is you have basically 3 mirrors, and then the reason it's offset like this is so you can pick off this light and then toss it into an instrument bay. So this is Mary, which is one of the instruments in the instrument bay. There's some cryo cooling systems in here and so forth. I saw an image with a person working on this, and they're about that high in the diagram. This is Murray, the mid-infrared instrument, and you can see the diagram here on the right, what it physically looks like, and there's various spectrometers and optics in that system. So this is sort of a summary slide of some of the kinds of science that James Webb can do. So this is Mary over here, and near infrared spectrograph. So spectrometry mapping, planets and objects. And then over here is the infrared camera, so you can get some nice pictures. And then spectrograph for exoplanet research. So there's quite a few research activities that will happen with this platform. I believe it won't be really coming online and calibrated till sometime May or so. So first light. So anyway, that is my talk. I hope you enjoyed it.
Thank you very much, Michelle. does anybody have any questions for Michelle? No questions. Well, what we're going to do is we'll take a 10-minute break. And what we can stay on here and visit and socialize, because we're not going to do an actual breakout room tonight. We'll just do it here as if people want to chat, you can turn on your video so people can see each other and chat for a bit. But we will take a 10-minute break, and then we'll start up at, looks like about 10 after 8 with our main speaker tonight. All right. Good. Tulloch?
I'm a guest. Cool.
The guest speaker. And Gord tonight is going to talk about dun, 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 boots on Mars this decade. Dun, dun, dun. Over to you, Gord.
Thank you. So, can everybody see my slides?
I do
Yes,
now.
we can, Gord.
Okay, you can see the RASC Winnipeg logo. So the problem with this presentation is that it got delayed a few times, and every time it gets delayed, I just keep adding more to it. So we may be here till 11:30 tonight, but I'll try to keep it moving along. So this presentation is part of the inspiration for it. I was at the Mars Society conference in, gosh, it's October now. And it was very interesting. It was 3 solid days of program, all virtual, all on a really nice platform that I'll have to go back to and learn a little more, because it's an excellent way to do an online conference. It worked really well, and there was a huge number of really interesting and very diverse presentations there. There was a lot of technical type presentations, and there was also things like, art and psychology and all sorts of stuff, all related to the potential for putting human habitation on Mars. So I couldn't summarize the whole conference. We'd definitely be here till 11:30, but I did pull a few slides that I found were interesting, and then I've kind of knit it all together. And of course, there's a lot of current activity that we can talk about, and you'll find I have a lot of opinions about some things, which won't surprise anyone, especially about things like what NASA's doing and how the entire military-industrial complex works for space exploration. So you'll hear all about that. So let's move forward. So people have been wanting to go to Mars for a long time, and one of the first really serious looks at how do you go to Mars was done by a fellow by the name of Wernher von Braun. He was a scientist in World War II on the Nazi side, who actually developed the V-2 rocket that went raining down on London. After the war, he surrendered to the Americans and immediately went into the American rocket program for manned missions to orbit and to the moon. And that was the time of Sputnik, and they were using the German rocket scientists to try to counter the Soviet rocket scientists who were doing all sorts of stuff. And Wernher von Braun wrote this book, Das Mars Project, the Mars Project, early on, and it's an interesting and very seminal work, because it's kind of influenced what I call the Battlestar Galactica approach to going to Mars. He advocated building significant infrastructure in orbit and then using that infrastructure to build giant spaceships, which you would then create fleets of and send off to Mars every 2 years. So the Battlestar Galactica approach has been one that has kind of permeated all of these different plans for going to Mars. And it's pretty uniformly sunk, every single one of them, because of the cost and the complexity. Another interesting one, and I actually got a really good book about this one, was called Project Orion, which was a nuclear pulse-based propulsion where you would just, again, this was the 50s when nuclear was great, right? So you would set off a nuclear bomb under the bottom of this rocket, and it had a big pusher plate with springs. So you let off the bomb and it would push it up. You let off another one, it would push it up, and you propel yourself that way. You wouldn't kind of want to be standing under it, but it was actually very, very viable, but it was absolutely wrecked by the nuclear non-proliferation treaties that came about in the early 60s. So that one was kiboshed by the mid 60s, never to be seen again. But next, I think after Apollo and everything else had petered out, and the logical follow-on for Wernher von Braun was to move on to Mars, and he actually built the rocket that was capable of taking us there. The Saturn V has 140 tons capacity to orbit, and it was quite capable of doing a single throw to Mars and allowing us to land there. Not quite sure how we'd get back, but that gets a little bit easier if you're on a planet that doesn't have as much gravity as Earth. But of course, the space program, people lost interest, politicians lost interest, and Saturn V's are now tipped over on their sides, sitting in a couple of different bases for NASA as exhibits. So in 1989, George Herbert Walker Bush decided that he would give it a try. So he created the Space Exploration Initiative. He put Dan Quayle in charge, which was death right away. It's doomed when Dan Quayle is in charge. But what really killed it is they actually, they were using the Battlestar Galactica approach, and they sent it to the Congressional Budget Office, and they came back with a price tag of $500 billion. Yes, that's billion, spread over 20 to 30 years. And of course, the infamous 90-day study pretty much kiboshed that. So at the same time, Dan Goldin became NASA administrator and started these faster, better, cheaper robotic explorations of space, which has worked extremely well and continues to. But meanwhile, humanity languished in near low Earth orbit. We got the space station out of the Space Exploration Initiative, but not a lot else. So we've been in low Earth orbit, going back and forth to the space station for a long time, 50 years. So in the meantime, the robots have ruled, and you've had robots since the 60s, Mariner 3, 4, 6, 7, 8, 9, Viking 1 and 2, landers all the way through the 90s with Mars Pathfinder. Pathfinder, if I can get a laser pointer going, this is Pathfinder, and this is Sojourner, one of the basically the first rover. And you'll notice the design is pretty consistent once you get to Mars exploration rovers, Spirit and Opportunity, which are unfortunately defunct now. In the meantime, they also had Mars Global Surveyor, Mars Odyssey, which is still operating since 2001. European Space Agency's Mars Express, still operating since 2003. Mars Reconnaissance Orbiter, still operating. MAVEN, still operating. ESA ExoMars, still operating. And Perseverance, finally, in 2021. And this is Perseverance 2. I was actually lucky enough to be in JPL when they were packaging Perseverance up and developing it. And so I got to see it firsthand and take pictures of it and stuff. So it was pretty cool to see that it's now on Mars. So the unfortunate thing, though, is, and somebody has put this really clear, if you dropped, Perseverance into the Rocky Mountains, it would take about 100 years for it to find a fossil, right? Because robots are kind of slow at doing things. You can't spot a neat-looking rock, walk over to it, hit it with a hammer to see what's inside, like a human geologist can. So there's limitations to what you can do with robots that are not limitations of people. So at the end of the day, you've got to get people on the ground and boots on Mars. So that's what we're going to talk about. So what have we been doing? Well, NASA obviously took us to the moon and has been instrumental in doing all of these amazing robotic expeditions to Mars and all over the solar system. And they have a lunar program called Artemis. And the lunar program uses something called the Space Launch System. I think it's called the SLS, and Orion is a capsule. And it's old space shuttle kind of technology upgraded to create a large booster that can get you to the moon. You can see there's two solid rocket boosters on the side like a space shuttle, a big fuel tank, and up here is the Orion capsule with its escape tower and stuff. So the SLS has been delayed and delayed and delayed, but it looks like they'll launch Artemis 1 around the moon in 2022, and Artemis 2, or they'll launch Artemis 1 in 2022. Artemis 2 will do a loop around the moon in 2024. Artemis 3 will be, I believe, a landing, and then you've got Artemis 4 as well. Interestingly, for a lander, they did a competition, and that was awarded to a company called SpaceX. Out of 3 different landers, they chose one that is actually also capable of getting there, but they're choosing it to be a lander. So there's a variant of the SpaceX Starship that actually is part of that program. Also part of that program is a satellite that's going around the moon called Gateway, and you'll hear about that in a sec, but Gateway has actually been taken off the critical path for Artemis, so we're not sure what the status of Gateway is moving forward. That would be essentially a space station going around the moon, and it would be a way station of some kind, and astronauts would go to Gateway, and then they would board their Starship to go down to the moon, and the Starship would bring them up, and then they'd go back into their Orion capsule and go back to Earth. Why? I don't know. It's sort of they're getting better. It's not quite a holdover to the Battlestar Galactica type days, but it's still not necessary. And arguably going to the moon is not particularly necessary. There's not a lot on the moon that is really of interest, except for helium-3. Helium-3 is a fuel that you can use for fusion reactors. Fusion reactors can either use deuterium and tritium, but when you burn those in a fusion reactor, it actually creates neutrons, which erodes the vessel that you're in. So it's not as good as helium-3, which burns clean. It doesn't let off a whole bunch of neutrons. So helium-3 is really, really good if you happen to have a fusion reactor, which we don't, and you happen to have a fusion reactor which burns tritium. I should say helium-3, which we don't. So the moon is a future possibility for interesting things, and also things like telescopes on the moon and that sort of thing. But really, it doesn't seem to be a critical thing other than for political reasons and for reasons that aren't good, like get there before the Chinese, that kind of stuff. If you want to go learn to live on Mars, go to Mars, because the moon is nothing like Mars. Mars is a lot more like Winnipeg than it is the moon. As a matter of fact, the Mars Society has a simulated habitation up in the Arctic, which is very similar to Mars in climate and that sort of thing. So if you want to go to Mars, go to Mars. And if you want to go to the moon, it's kind of a sideshow and not really on the critical path to human habitation outside the Earth. But part of the problem is the whole Artemis moon program is nearly $93 billion. That's billion. And through 2025, so it's going to cost about 4.1 billion with a B dollars per launch. And obviously, that's kind of expensive. A billion here, a billion there, it starts turning into real money. So that's the NASA plan. So we're going to get 4 flights to the moon in Artemis, and then there's saying there will be a follow-on going to Mars, and we'll talk about that in a sec. SpaceX, on the other hand, which is space exploration, Elon Musk's company, is already building and testing Starship, which is a large rocket and booster combination that is intended to be a vehicle for not only going to Mars, but deep space. And we'll talk about it in some depth. So they're already building and testing that infrastructure. We've got possible launches actually next month to orbit, and then possibly in the next conjunction with Mars, we could be launching uncrewed missions to Mars, and 2 years later, crewed missions. So we'll talk about that. And of course, I said they're providing the moon lander for Artemis. Other players, Blue Origin, Lex Luthor, not Elon Musk, Jeff Bezos' company, Lex Luthor, as I call him. They're players, but so far they've gotten to the point where they make mock-ups of things and not actually flown much in the way of this kind of rocket. Obviously, he has his recoverable rocket to go to low Earth orbit, or actually, it's not even low Earth orbit. It's suborbital. But when we're talking about boosters and large rockets, we're talking about big stuff, and they haven't got there yet. And there's not a lot of other players in this space. The one thing he does have is reusability, which is a big thing in rockets, and is really an enabler for us to get to Mars and beyond. Any questions so far? Okay, so this is the latest version of the Mars Deep Space Transport scheme of NASA. It's not been updated. Deep Space Gateway is the satellite around the moon that they want to build. They haven't built it yet, and it's unlikely it will get built for Artemis, so I'm not sure where it plays in here anymore. It's probably gone, and probably for good. So the plan here is that we send Orion, and we use SLS boosters to send Orion up to Deep Space Gateway. It hangs around for a while in this deep space transport that they'll send up as well. It actually was going to, it would be launched in 2027. It would hang out in lunar orbit for a year before doing a cislunar flight in 2029, and then an opposition flight to Mars. And opposition flights are not a great idea, which we'll talk about. So it all seems a little strange and really, this diagram particularly is a little odd as far as how long it takes. But this is kind of the scheme. Essentially, they're going to build a piece of hardware called the Mars Deep Space Transport. It's going to be boarded in lunar orbit, and then it'll fly to Mars. It'll spend a relatively short amount of time on Mars and then fly back. And then they'll board their Orion spacecraft in lunar orbit and come back to Earth. So that's sort of as much of the plan as they've got. None of this hardware other than the Orion capsule actually exists. So it's quite a ways out. And Robert Zubrin, who is the president of the Mars Society, has said, something very, very important, like this looks like a vendor-driven plan drawn up without the constraint of a requirement for mission success. And really that's what's endemic with the NASA programs and government programs in the US and other places, is it's very vendor driven. In other words, you give vendors a cost plus contract. They are incented to make sure their costs are as high as possible and drive out the schedule for as long as possible because they make more money that way. Whereas an engineering type mission would be, do it as cheaply as possible to achieve the mission, right? And that works out a lot better, and that seems to be a lot more aligned with the SpaceX kind of model. So why is SLS still a thing? Well, being a little unkind, perhaps, it's corporate welfare for the U.S. space industry. Like, there's a lot of jobs and a lot of contractors that are being supported by this project, billions and billions of dollars. Now, I was kind of down on the whole conjunction versus opposition, so I wanted to talk about that a little bit. We're astronomers, so we understand what conjunction is. That means, and it's sort of heliocentric. So when Mars is in conjunction with the sun, it's behind the sun. And when Mars is in opposition to the sun, it is on the opposite side of our sky from the sun. That's what conjunction versus opposition means. So when you launch a spacecraft, basically you fire its rockets until you reach enough speed that you go into an orbit around the sun. So you escape Earth, you go into orbit around the sun, and you contrive your orbit such that the highest point of your orbit just happens to correspond with the orbit of Mars, just happens to be when Mars is in that space, right? So there's two ways you can do that. You can leave when Mars is on the opposite side of the sun, and that's the lowest energy type orbit you can get. It's, you know, at its least energy is called a Hohmann transfer. So you can transfer from Earth's orbit to Mars's orbit with the least amount of energy expended, and in other words, the smallest rocket. You know, the more energy you need, the bigger the rocket you need. So a Hohmann transfer takes quite a while. So there are modified Hohmann transfers, which will get you to Mars in 6 months, right? So it'll take you 6 months in space from the moment you leave Earth to the moment you arrive at Mars. And that's a low energy orbit, and that's a conjunction based orbit. The nice thing about that is, although you're in space for 180, 198 days in this case, you actually get 558 days on the planet, which is good from my perspective because you're there to explore the planet. Why would you want to leave early? The other type of orbit is an opposition type orbit. In other words, when Mars and the Earth are closest together, right? Because essentially, Earth is, the sun is here, Mars is here, and Earth is between the Earth. That's conjunction. So if you leave Earth and you do a conjunction type trip, your travel time to Mars is a little shorter, not huge amount, I'd say, about 20 days shorter, but you only get 40 days on Mars. And they think that's a good thing because Mars is a dangerous place. We certainly don't want to hang around on Mars too long. So let's only spend 40 days there. And then actually the departure after that 40 days is kind of circuitous because not only is it longer, but it actually takes a swing past Venus so that it can get its orbit adjusted so that it can be put in an orbit so it intersects with Earth. It's called a flyby, F-R-Y, because you're going into the inner solar system. There's more radiation. It's more complex, and it takes a lot longer. So you're actually out in space a lot longer. So this is a bad idea, but it seems to be favored by the powers that be because you have a short time on the planet, and the planet's a dangerous place. And the reality is, space is actually a dangerous place, right? You can make the planet less dangerous. There's a lot of things you can do, and you don't need as large a rocket to get from Earth to Mars with a conjunction orbit because it uses a lot less. So your total change in velocity, delta V as it's called, for conjunction is about half of what it would be. So you need a rocket that's half the size, essentially, putting it simply. So I'm just going to check the chat. Oh, good. So, if you want to learn a lot about orbital mechanics, there's a game called Kerbal Space Program, which is the best thing I've ever seen on how to do orbits and things. It's a great game that simulates a space program in a planet called Kerbal, which looks a lot like Earth, and they've got a moon called Luna, and they've got a Mars is called Duna. So they've got a lot of the same bodies in their solar system that we do, and the physics about orbits is actually quite similar and quite realistic. So if you ever want to learn all about orbital mechanics, get Kerbal Space Program. It's on Steam. Any questions about that? Everybody's gone for coffee, probably. So, SpaceX Starship, this is a picture of Starship. It is quite a large vehicle. It's can never remember the measurements. It's 320 feet tall. It's about 100 odd meters tall completely. The ship part, which is this part T here, you see the dark tiles here. These are actually heat absorbing tiles for reentry. Is I think it's 60 meters, and this is about 80 meters. So this is quite a large vehicle. As a matter of fact, they've got the Saturn V that took man to the moon next to it for scale. So it's actually quite a bit larger than a Saturn V. It's 9 meters in diameter. The original version of this was actually quite different. This is made out of stainless steel. The original version was supposed to be carbon fiber. It was actually supposed to be 12 meters in circumference instead of 9. It was called the BFR, the Big Effin' Rocket. But they realized that stainless steel is a lot cheaper and easier to work with, and it actually reacts well to heat, so that if these tiles do get penetrated by the plasma that's generated when you're coming back to Earth from space, it won't necessarily burn right through and cause extreme damage in the rocket. So stainless steel is cheap, easy to work with, and turned out to be the best material. So this rocket looks like it's been banged together out of with a pair of tin snips and a hammer, but in reality, it's cheap to build and very effective in doing what it does. So they've built a number of prototypes of this rocket. And what I did is I put together a bit of a collage of videos. Actually, Elon Musk did a status report last night, and they had a really good video. So the part at the beginning of this video I'm going to show is from that announcement / status report that Elon Musk did last night. And it's also includes some other footage, and I'll narrate it as best I can. So I just have to remember how to show videos. So I'm going to stop sharing. And I'm going to, you remember where that is, Ed? We were playing with it last time.
Remember, I'm on my cell phone this evening. Sorry.
Oh my goodness.
Might be under the video. Like, is it the drop down on video? Maybe. Is there a drop down over there?
It was easy to find last time, wasn't it?
Yeah.
Share. Files. Okay, got it.
Okay.
Let's see. I'm going to share a video. There we go. I discovered last time I did a presentation where I shared a video that you really want to do it the way they want you to do it, or it doesn't work so well. So here's a video about Starship. This is Boca Chica, their manufacturing facility where they built these things. And as you see, it is clearly stainless steel. Those are the engines they use, are called Raptors, or conversion. One is for ground level and one is for vacuum. So this is the Starship upper stage, second stage of this rocket. It's quite large. Some of the test flights. I think this is the first one that didn't blow up on impact. It actually blew up 4 minutes later. This one is the first one that landed successfully. Notice it's kind of falling, and then it ignites the motors and lands on its tail like Buck Rogers kind of rocket. So the reason it lands like that, it actually falls on its belly to minimize the speed it gets to. It only gets to about 237 kilometers an hour due to, its terminal velocity, like a skydiver, essentially gets to 237 kilometers. So it re-enters the atmosphere, falls on its belly at a relatively slow speed, and then at the last moment flips over on its tail and ignites a couple of engines to land softly, propulsively. So this is really one of the innovations that have come about, where they're actually recovering this entire vehicle end to end. Most rockets are expendable. In other words, you fire them off and it stages, and the stages burn up in the atmosphere or fly around in space. This is a fully recoverable rocket. The Starship portion obviously is where the cargo or the crew would be, and this beast here is called Super Heavy. It's the booster that gets it into orbit. This is just a test fire of the Super Heavy rockets. This is the stacking. It gives you some idea of scale. This was the night before last, where they did another stacking of the complete rocket booster. The platform that's being used is actually called Mechazilla. They have great names for these things. And Mechazilla is basically a giant crane. And when the rockets are ready for use, it lifts them up and stacks them so that they can be fueled and go. But the really interesting thing too is they don't land propulsively on a platform or anything. They're actually they land and are caught in midair by these two large chopsticks, they're called. And the reason they call them chopsticks is because of the movie Karate Kid with catching flies with chopsticks. So they're kind of doing the same thing. So the Mechazilla is the tower, and the chopsticks are the things that are catching the Starship out of midair, and the booster. You'll see that in a bit. That's for fueling the booster. I think that's coming up there. Now this is obviously a CGI of an actual Mars mission. You see they've got multiple launch stands. This is off pad 39A in Kennedy. They're starting to build these pads now. There's a production facility. You can see the Starship on top of the booster. After the booster has done its job, it actually will flip around and burn back towards its launch pad, while the second stage, the Starship, carries on. So the booster will re-enter. Notice the grid fins on the top of the booster. That allows it to clear as it falls through the air. And then, similar to the Starship, it fires a couple of its engines, and it is caught by the chopsticks. Chopsticks can now put it back on a launch pad, and it can be refueled again while Starship is off to Mars. The important part of getting to Mars is on-orbit refilling. They call it refilling because it's mostly oxygen as well as fuel. So they use oxygen and methane as fuel. And they probably have to refill with 4 or 5 different tankers before they're full of fuel, ready to go to Mars. The crew compartment of these things are so large they can hold about 100 people if you're cramming them in. Probably not that many go to Mars. So 6 months later, we arrive at Mars. There's Olympus Mons, largest volcano in the solar system. It kind of gives you an idea how big it is. Valles Marineris. Of course, you don't send only one of these at a time. You can send many of them. SpaceX indicates their plans are to build 1,000 Starships. Yeah, and that's good. So, I'll share my screen. Any questions about that? That kind of gives you an idea of what a flight would look like. It's similar to this. The one thing that's important to note is part of the risk mitigation around flying people to Mars and staying for 500 odd days is you got to have redundancy, and the redundancy that they're planning on having with the SpaceX model is they're going to have a lot of starships. They're going to send whole fleets of these things, kind of harking back to the Battlestar Galactica kind of model. But you're going to have these rockets, which are relatively inexpensive, and we'll talk about that in a sec. And you're going to be able to build a whole bunch of them because they're mass produced. Right. One of the things that SpaceX is really good at, because of Elon Musk's background with Tesla and all that sort of thing, is creating a manufacturing model for making a whole bunch of these things, as opposed to making everything one-off and essentially flying a prototype. The way they test these things is they build them, they fly them, they break them, they figure out why they broke, they fly in, they build another one, fly, break it, figure out why it broke, and keep going until you have a working system. NASA doesn't really do that. NASA tends to pretty much fly the prototype, and hence it's very expensive because it has to be perfect the first time, right? These have to be perfect the first time it flies people.
Gord, you have a question here, a couple of them. First one was to clarify the human containing part doesn't need the chopsticks.
Yeah, it does. It'll land on the chopsticks.
Okay, the next question, there was this question, what about radiation effects on people traveling to Mars?
So radiation, you'll get about 60 rem on the way back and forth to Mars. So 100 rem all at once is life-threatening. 60 rem over a period of time increases your chance of getting some life-threatening cancer by about, I think, about 5 or 10%. So there's, okay, Anne, I understand what you mean. Yeah, the radiation effect, of course, the radiation effect is there, of course, and you've got cosmic radiation as well as you've got potentially events coming from the sun. So you will need to be able to, for example, have a shielded area in the spacecraft that people can go if there's a coronal mass ejection or something happening on the sun. But the for cosmic rays and just sort of background radiation, you're not pulling in enough to seriously jeopardize your life over the length of one of these flights. Of course, you want to minimize it, which is why the conjunction flight is much better, because you actually spend considerably less time in space, right? Chopsticks on Mars, no, there's no chopsticks because the gravity on Mars is so much less than Earth. They can do just a propulsive landing. So they do the belly flop, they fall through the atmosphere, and once they get close to the ground, they flip over and do a propulsive landing on Mars. That's until they build the infrastructure and they build some chopsticks, which will probably take quite a while. Similarly, because the gravity is so much less on Mars, they can do a propulsive takeoff without needing a booster, right? The moon has water, but it's very difficult to get. Water is, we'll talk about water in a bit. So we'll carry on because otherwise it'll take a long time. So economics, the cost to build a starship based on volume, essentially once they've got their production line up and running, it costs about $37 million to build a starship. That's an M, by the way, 37 million, not 37 billion. At 2 starships a week, the economics get much better, and they are looking at building 1,000 units. They want to get this down as low as possible. So you're talking about $13 million a unit. These are not horrendously expensive. Super heavies, again, they're going to build a lot of them, not as many because they don't need as many of the boosters. So they're going to work out to $32 million each. That's not exorbitant, right? That's actually achievable. That's not all that different than an airplane, right? So starships and Super Heavy are completely reusable, and they've had boosters for the Falcon, which is the smaller rocket that SpaceX makes, that have been reused 10 times already, right? So they're well versed in this reusability. So they're expecting they'll reuse these starships and Super Heavies about 100 times before they're worn out and they have to be retired. So they want to get the per flight cost down to $2 million. So it's going to be somewhere between $2 million and $10 million a flight. So when you talk about 100 tons to low Earth orbit, 150 tons to low Earth orbit, 100 tons to a higher orbit, I think 30 tons to geosynchronous orbit, it means that if you want to fly people, 120 people per flight means 20,000, 10,000 a flight. That enables the use of these machines as actually point-to-point on the planet type conveyance as well. So you can fly a 40-minute flight between New York and Shanghai on a Starship, Earth to Earth, and the cost is similar to what an airline flight in business class, much less one of those super luxury class, that take 20, 30 hours. It would take 40 minutes. So essentially, 40 minutes means that if somebody breaks a very important machine in Shanghai and the part is in New York, it's possible to get it there same day. And that's kind of groundbreaking as well, right? So we'll talk about timelines in a sec. So 40 minutes between New York and Shanghai, Earth to Earth, overall operations costs are offset by other things. For example, they're going to use these things to launch a bajillion Starlink satellites at a time as well. And then flights to Mars are kind of like ships to North America. If you're going to fly to Mars, you're probably selling everything you have if you're going to go to stay, and that's how you're going to get to Mars if you want to emigrate. So this is actually older. Obviously, Ship 20 and Booster 4 have been stacked, but you can see the pipeline here. They've actually got Ship 21 and Booster 7 almost ready to go. So essentially, you've got a pipeline of these things being built. So if Ship 20 and Booster 4 explode on the pad, that would be the worst scenario because it would take them a while to repair the pad. But they are not expecting Ship 20 and Booster 4 to get to orbit. But if they do a rapid unscheduled disassembly somewhere along the way, they're going to get a lot of data. Ship 21 and Booster 7 are in the pipeline. They'll fly those, and eventually they'll get them to orbit. Once they're in orbit, then they can do things like learning how to do in-orbit refueling and that sort of thing. So that's their approach, is to fly lots and learn lots, even if you blow them up. Now, I mentioned that NASA actually has contracted for a lunar version of the Starship. So it's a slightly different thing, but generally it's the same. The big difference will be it will have some form of landing gear, and it will have rockets on the side, similar to what they have in their Dragon capsules, so that instead of all of the thrust coming out of the bottom and digging a great big hole in the moon, which is a bad idea, kicking up a lot of dust, they've got these thrusters on the side. So this would be the version that would go to the moon. They have a cargo version, which will be what they load all of the satellites and things into. They have a tanker version, which will bring fuel up to the crew version, which is the kind that will go to Mars. And then they're talking about a deep space version, which would go beyond Mars. The fuel is actually methane and oxygen, yeah. And there's a good reason for that, which we'll talk about in a sec. Now, quickly, Robert Zubrin, whose name I mentioned, he put out a book in 1996. It was recently revised in 2011. Actually, there's a new version out called The Case for Space. He was the first one to offer an alternative to the Battlestar Galactica motherships model, where essentially you're doing a single throw to Mars. You're sending ships that are relatively cheap and simple, and you're using something called in situ resource utilization to actually generate fuel and other materials right there on the planet. So he's actually the founder of the Mars Society. I'm a member of the Mars Society of the International Mars Society, as well as the Mars Society of Canada. I've been a member for quite a while. And so the Mars Society has undertaken a whole bunch of projects like simulated habitations in the Arctic and actually in the desert that allow you to simulate life on Mars, and have undertaken a lot of projects to develop technology that could be used on Mars. So the Mars Society is really intended to assist in further development of plans to take humans to Mars. It has obviously gotten a huge jump start by the recent technologies that have started to come out of companies like SpaceX, right? So it's gotten very exciting, which is why, they have these huge conferences with many, many people to talk about things they can do to assist, right? So Mars Direct is a little weird though, so this is the plan that the Mars Society has put forward. And I actually don't think it's going to be how things work, but it's interesting to see the wrinkle they've added. They're, obviously they're assuming that Starship is going to be the vehicle that takes us to Mars. Their suggestion was, and this is one of the presentations from the conference, that they build a mini Starship which would be cheaper and allow you to use less fuel and just generally reduce your overall resource requirements for getting back and forth to the surface of Mars, rather than having all of these starships all operating and using up a lot of resources because they're big, right? So the SpaceX architecture is land on Mars with starships, refuel them via water electrolysis and Sabatier reaction, which we'll talk about in a sec. But they feel it relies on Martian ice extraction and processing for generating fuel. It relies on solar power and no plan B in case of in situ resource utilization failure. In other words, if they can't make fuel, then that's a problem. But that's a problem for everybody, right? So their suggestion is make these smaller ships so that they can use less fuel. And a Starship requires 645 tons of fuel, which requires 1.13 megawatts of power to generate, and has a large mass of solar panels that it would need to have to provide electricity to power the electrolysis of water into hydrogen and oxygen, and to power some of the other reactions. So the thing is, and I'm going to go over through this quickly because really this means that SpaceX would need to develop a whole new vehicle. And I don't think they're going to do that because SpaceX is very focused on manufacturing and development of their product. And they will use starships and just make more of them because it's incredibly cheaper to just make a whole bunch more starships at not a lot each, versus an R&D project and setting up a whole production line of these many things. So good intentions, smart idea from the Mars Society. I don't think it's going to happen because 42 launches when you got 1,000 starships, who cares, right? They're nickel and diming a little bit by making these smaller starships, but it's really a false economy because you have to build these new ships, you have to do the R&D, you have to do the testing, and that's much more expensive than just banging together a whole bunch more starships. So talking about in situ resource utilization, hopefully this will answer some of the questions. So Starship runs on methane, CH4, and oxygen as the oxidizer. That's its fuel. So Mars, its atmosphere is 95.3% carbon dioxide. So it's got carbon and it's got oxygen. We're missing the hydrogen. Well, what has hydrogen in it? Well, water has hydrogen in it. It's H2O, right? So you've got hydrogen and you've got oxygen in water. So if we could go to Mars and find a whole bunch of water, that would be cool because then we could just split it into hydrogen and oxygen, put it through a reaction, and generate methane and oxygen for our rockets. Now, the reaction and the apparatus that is used to generate this rocket fuel is a Sabatier reactor. And I may be saying that wrong, but whatever. So what it does is it pulls in Martian atmosphere, it compresses it, puts it through the reaction, adds hydrogen, and the output is methane and water. The water is obviously collected and electrolyzed and pushed back into the reaction as hydrogen, and the oxygen is obviously saved because that's the oxidizer for the rocket. The other thing that comes out is methane. That's condensed. It has its water extracted, compressed, and it's put into the gas tanks, right? So basically the Sabatier reaction, when you add hydrogen, will take carbon dioxide and make rocket fuel, which is great, right? All you need is hydrogen. However, Graham, what's the comparative carbon footprint? You'll have to look that one up yourself, Graham. Probably less because burning methane and oxygen results in water, right? And CO2. So anyway, I'll leave that up as an exercise for the student to figure that one out. But the Sabatier reaction allows you to take Mars atmosphere if you've got hydrogen. If you can't find water, though, you can bring hydrogen with you. You've got 100 tons of cargo capacity in a Starship. You will get boil off and during the trip of about 15%, but you only need 10% of the volume of hydrogen versus 90% of the volume of carbon dioxide to produce your rocket fuel. So you're sending a whole bunch of Starships there anyway, might as well fill a few of them up with hydrogen, and that will kickstart your entire process, right? So that's one way you can avoid having to go looking for water in the first place, is you send a bunch of Starships full of hydrogen. And you send a bunch of Starships full of hydrogen in the 2 years before that you're going to send people. So these Starships can be sitting on the surface manufacturing fuel, and you don't actually leave the Earth until you're sure that you've got full gas tanks on your rocket that you're going to be coming back in. And that adds a lot of redundancy and risk mitigation when you're actually sending a lot of redundancy ahead of time, and you know that redundancy is actually operational before you actually leave Earth orbit to go. So I'll talk about water on Mars a little bit in a bit. Like I said, I don't want to be here till 11:30. So actually, we're doing actually not too bad on time. So here's what I think is probable. You know, looking at what the Mars Society is doing and looking at what SpaceX is doing, every 2 years, there's a window of conjunction. Conjunction is best, right? I don't think there's any argument, and I don't know why NASA is arguing with everybody else about using opposition type missions. Window 0, 2022-23, right? We have, obviously, opposition is this year. We're going to all go out and enjoy Mars this year. So 2023 is a conjunction year. So window 0, they'll be working on getting Starship into orbit, lunar flights, learning how to do on-orbit refueling, and adding additional launch capacity at the Cape. And they'll be doing orbital reentry landing tests on Mars potentially in 2023 if everything else goes well, because they, like I said, they got lots of these things, so they can send them out there. The really important window becomes 2025, where you can now send cargo Starships with solar arrays or nuclear reactors, and we'll talk about that, so that you can get power for your in situ resource utilization, so you can generate your fuel. You're going to send hydrogen feedstock, right, so that you can kickstart that whole process of extracting carbon dioxide from the atmosphere and reacting it with hydrogen to create methane and oxygen to run your rocket. And you're also going to send a crew Starship, uncrewed, which is your Earth return vehicle, which is the thing you're going to fuel, right? So you're going to have the fuel factories pumping fuel. You'll have robots that'll, be hooking these things up, and essentially your Earth return vehicles will be sitting on the surface fully fueled before the start of the next window. The start of the next window, you send people. So you send crew Starships for the first manned landing on stars, on Mars, and they will only leave if they know that the Earth return vehicles are actually ready to go. You can also send, of course, additional crew starships, because, hey, you got 1,000 of them, right? Send the uncrewed spares and fill them up with rovers and all sorts of stuff, equipment, and you've got extra capacity there. Worst case, you've got something the size of a building, standing on Mars that you can use to base your base, right? Cargo starships can also be used for truss assemblies for spin gravity, and we'll talk about that in a sec. And obviously, you've got solar power, additional solar power, nuclear reactors, ice mining supplies, in situ fuel, hydrogen, and rovers and things. So this is what the windows look like, right? So the first window, you're sending the supplies that you'll need for the crewed starships 2 years later. And that becomes a cycle. And that's how you start building up a large presence on Mars. You start sending a lot of these things, and every 2 years, a whole fleet of these things are heading toward Mars from Earth. And I'm going to hold questions till the end. So artificial gravity, we'll just talk about that for a sec. So obviously you've got a cargo starship, and the people have figured this stuff out, right? So you've got a cargo starship, you put a 100-meter long truss assembly in it, and in orbit, you assemble that truss assembly, or I should say en route to Mars. So you've got a starship that has that truss assembly, and you've got 2 crewed starships that you want to create artificial gravity on. So you build out this truss assembly, you attach 2 starships to them, and you put them on an axle so they can swing. You fire their rockets to get up to 2 rotations per minute, which would require about 3 tons of fuel to start, 3 tons to stop. And you basically get Mars level gravity by spinning them. So once they're up to speed, they rotate so that they're tail first, and these things are now spinning around and generating gravity. Because they're on such a long truss, the Coriolis forces will not be debilitating. In other words, like, you're not actually experiencing gravity, you're experiencing spin, and that can be disorienting, right? So all of this stuff can all be used with essentially the same base hardware that they're going to be using for everything else. There's a link to this stuff. Nuclear power, this was a really interesting presentation at the session. Dr. David Poston, he was talking about, for Mars, obviously, you need electricity and heat to create oxygen, to create a source of water, to power the habitats, to do all the drilling, melting, heating, and refrigeration, sample collection, all the stuff that you do. We've developed an infrastructure that uses electricity as the middleman for almost everything. So generating electricity on Mars is quite important. So abundant electricity is needed to make liquid oxygen and methane. So to use in situ propellant production, there's 2 ways to do it, really. One is solar power. So you can create a whole bunch of solar panels and drop them onto the surface, and they'll collect sunlight, right? Because it's sunny in Mars. All of our robots that have gone to Mars have used solar power for training, or they've I think one of them used a nuclear, can't remember what it's called, but anyway, so solar power, essentially we've got solar powers, but it does represent some major challenges, right? You've got half the flux that's coming from the sun. You've got long-term dust storms, although chances are dust storms are not as big an issue. We haven't experienced them as being as much of an issue because actually dust collecting on the solar panels tends to get blown off by the wind, right? We've noticed that with the probes that we've sent, the rovers that we've sent. But dust storms are a problem because they do attenuate the sunlight, so you don't get as much power. Much colder, longer nights than Earth. Highly dependent on latitude, so you have to pick the right latitude. Your terrain will block sunlight. The moon can be even more challenging because you got 14 days of darkness, huge temperature swings, and obviously you need a lot of power to extract ice from craters. So a better scenario would be to put some sort of nuclear fission type device in your base so you can generate electricity with nuclear fission. So this team, called spacesuit.com, are essentially creating one of the first nuclear reactor designs that have come out in the last 30 years. So they're using these crusty cores, they're called. So they're 10.7 kilograms of uranium. The fact that guy's using I should say using gloves, is not to protect him, it's to protect the actual uranium core from oils on his skin. So this stuff is not radioactive more than very, very low levels of natural radioactivity in the uranium. And essentially one of these crusty cores can be used to generate as much energy as one fully fueled Falcon Heavy rocket, right? Which is a lot. 43 megajoules per kilograms of fuel on that. So 6.7 to the 6 times 10 to the 6 megajoules of energy. That's a lot of energy. Let's just leave it at that. So these kilopower reactors that they've developed allow you to get 1 to 10 kilowatts of low mass to the planet, or up to 25 kilowatts for a larger system, adapt them to operate in space or on the surface, those big things that look like hats or radiators, and you can generate a fair bit of electricity without worrying about sunlight. So the combination of solar and these kilopower reactors seems to be a really good approach, so that you don't have to necessarily wait till you've deployed hundreds of kilometers worth of solar panels to begin generating power to power the creation of your fuel for your Earth return vehicles, right? So nuclear is really developing quickly, and they're developing nuclear specifically for the purposes of putting them onto a planetary surface to fuel in situ resource utilization. So where's the water coming from, was a question. There's a lot of water on Mars. They're discovering a lot of the previous probes have found things like dark, narrow, 100-meter long streaks they're called recurring slope lineae, flowing downhill on Mars, which seems to indicate water. Planetary scientists have detected hydrated salts on the slopes of the crater, which are all indications of water. Recently, water was detected in large quantities beneath the surface of Valles Marineris, one of that huge, long trench on the surface of Mars. Mars Express has been orbiting the red planet since December 2003, carries a scientific experiment called MARSIS. And the purpose of MARSIS is to investigate subsurface water, right, up to a depth of 5 kilometers. And this has, you'll see this image here, the MARSIS image is indicating there's significant subsurface water in Mars. And it could be actually liquid water, and not only ice, but they could have hydrothermal vents, and you could get liquid water, which is great because you just pump it up to the surface and put it into your electrolysis process to generate fuel, right? So it's not a great idea to be completely dependent on it right out of the gate, but it seems to be readily available once you're established and are able to do some exploration. Finding water on Mars doesn't seem to be a problem. So this is one artist representation of drilling for it. Another scheme is actually to have rovers which just scrape the regolith off the ground, because if you heat that, it will actually release a little tiny bit of water, but cumulatively you can collect a lot of water and process it. So that's one way of mining water, in addition to drilling a hole and hoping water comes gushing out, or going and mining ice, which would be like mining anything else. You got to dig a hole and extract it, crush it, run it through a process to extract the water. But at the end of the day, once we have some boots on Mars, actually finding water and extracting it becomes a engineering problem that we're familiar with from Earth, right? We're just happen to be doing it on a different planet. So when are we going to go? And this is my ticket that this came from NASA. You can tell it came from NASA because it says 2026, which is a opposition year. So definitely not going on 2026. But the current status is the Starship program is delayed by an environmental approval. The U.S. government is doing an environmental assessment for their plant in Boca Chica, Texas. The reason they're in South Texas is that it's actually more southerly than Florida, where Cape Canaveral is. And you want to be as south as possible because you get a boost from the rotation of the Earth when you launch your rockets. When you're close to the equator, you launch them east and you can add the velocity of the rotation of the Earth. So next conjunction window is late 2023. I expect there will be flights happening. They will probably not be NASA flights. I think SpaceX will be doing it on their own. And every 2 years after that, we can see additional flights. So if you want to get on a flight, get your resume out, send it to SpaceX, and maybe they'll want you to be on one of their flights eventually. If they're sending hundreds of people at a time, the likelihood of it happening is a lot more than the very, very few people they're going to be sending on NASA flights and government flights. So the exciting part is you've got somebody who has virtually unlimited resources who says he wants to die on Mars, right? And there's a quote down there. I want to die on Mars, just not on impact. And I think, oh, okay, this one. So why are we going to bother? Well, you know what? For a fraction of the, first of all, the actual budget of NASA, if we want to use NASA as an example, is a fraction of a percentage of the gross national product of the United States. It is not a lot. It is a fraction of the cost of an aircraft carrier program. So we could be on the surface of Mars for a lot less than it costs to build maybe half an aircraft carrier. So for the fraction of the cost of a military program, we are not diverting a lot of money away from helping people. It would be great if we diverted some money away from making guns and ships and airplanes and make humans an interplanetary species. You know, we want to facilitate resource exploitation off-world instead of doing it on Earth so that we can get started on cleaning up the Earth. So we need to develop new technologies. We need to get out to Mars. And once we're in Mars, we can get out to the asteroid belt and start exploiting resources off-world and start protecting our planet. Obviously, space tourism is an interesting thing to a lot of people. And having a launch system where it's actually affordable, well, maybe if you're quite wealthy, but it's affordable for you to get an orbital flight. That's quite an advance for space tourism, and companies will be able to launch things into orbit that create that space tourism. We want to advance science, obviously. Boots on the ground beats robots every time. We will accelerate the pace at which we learn all about Mars by having people there. We want to create new frontiers for humanity. And this is important because, you know, humanity doesn't evolve based on comfort and being in safe places that a whole bunch of other people are. Humanity evolves on the frontiers, and this has happened all through history. Humanity evolves on the frontiers, so we need to be challenged with the frontier. We need to have a frontier to push ourselves forward instead of sitting and being complacent, as we have for the last 50 years, puttering around in low Earth orbit. Now, I didn't say these were good reasons, but of course, beat the Chinese is always a reason that seems to be popular with politicians, at least. So, you know, the elephant in the room is, I said the word SpaceX, and I'm sure some people spat. SpaceX has some interesting, has some aspects to it that are less than desirable for astronomers. Really, the Starlink satellite internet system is what's going to fund space exploration, right? The money that's going to come in from these satellites is going to pay for all of those starships. So that is a terribly inconvenient thing, I know. Evolution can have its inconveniences. I think this is, you know, I urge you to take the long view here. This is an evolutionary step for humanity. We will have things that are annoying and less than desirable, but when you take the long view, for example, if you're a radio astronomer, I'll pick on Michelle. If you may experience a period of time when you have less than optimal results with your earthbound radio satellites. What you're going to get is the capability to put radio satellites into, spitballing here. Let's put a kilometer-sized dish into each of the L5 points and have a radio telescope the size of the solar system. How is that going to happen other than technologies like what we're talking about? So yes, Starlink satellites are crappy. They screw up our pictures. They screw up, a lot of astronomy. They are working on it. They're actually working closely with a Japanese professor to make the satellites less obtrusive, with varying results. The first version they had actually was great. It radiated much less in visual range, but it radiated much more in infrared. Yeah, so the infrared astronomers were kind of upset. So they've got a new version actually that they're working on, that they're deploying and testing. So I think, I think Elon Musk views it as an engineering problem more than being sympathetic to astronomers, but they're viewing it as an engineering problem. They've gone through several iterations of the satellite to try to find one which is least damaging to astronomers, and I think that's a responsible thing for the company to do. I'm not sure other companies that are going to do this are going to be the same way. For example, Jeff Bezos is going to do the same thing with the constellation of satellites. He may be less likely to be cooperative. So, hopefully SpaceX outcompetes him and he doesn't put anything up. The idea of a Kessler cascade is another thing that commonly people bring up, where you have a whole bunch of satellites, you're filling up low Earth orbit with so many satellites, the potential for them to run into each other, even accidentally and potentially on purpose, could create a cascade where the debris from satellites that have run into each other gets spread about low Earth orbit, impacting other satellites, and you have a large cascade, which renders low Earth orbit extremely dangerous and potentially locks us out of the sky. The only thing I can say is that we have no capability to clean up low Earth orbit right now. If you had a ship that cost $2 million a flight and had 100 tons of cargo capacity, you could potentially send it up there and clean stuff up, right? So developing the technology that allows us to get into low Earth orbit or Earth orbit cheaply gives us the capability to do many things. The other thing I was thinking of, one of Michelle's earlier slides saying that the James Webb was not serviceable. Well, yeah, it would be if we had the capability to go service it. We don't right now, absolutely. So it's not serviceable. But if we can put starships on Mars, we can send them out to L5 to service James Webb, right? So we don't get to Star Trek without getting something like Starship. Is really what I'm saying. So I know I sound like a total SpaceX fanboy here, but it's the only game in town. So I think they need our support. So the Mars Society of Canada, just putting a bit of a plug in for Mars Society. I've got the URL on the next slide. They're sort of just getting started. I think they're focusing mainly on universities, and we are, I've had some talks with their president about starting up or restarting a Winnipeg chapter. There was a Winnipeg chapter, but it's kind of fallen by the wayside. We're talking about restarting a Winnipeg chapter of the Mars Society of Canada as more a grassroots kind of organization like Royal Astronomical Society, as opposed to a university sort of research focused type thing. I was at their annual, or I should say, I was at a visioning meeting with the Mars Society of Canada, and a lot of the people there were university students. Were talking about research, right? Which is great, but you got to pay for the research, and you got to have an organization that can help, put on symposiums and get money and go for grants and all that kind of stuff. So the Mars Society of Canada needs to do more than research. So if you're interested in helping start up a Winnipeg chapter, let me know, because I think something will be happening fairly soon. And now I think I'm going to go look at the chat. Scroll all the way back. Does anybody want to ask any questions out loud? How are we doing on time? Oh, pretty good. So Mark Irvine asked, I thought one of the reasons for using the moon was as a waypoint, so not as much fuel was needed to lift from Earth to travel to Mars directly. Actually, it costs roughly the same amount of fuel to go to the moon, land on the surface, come and go to Mars as it costs to go to Mars. As a matter of fact, I think it costs more if you decide to land it. From lunar orbit. It costs about the same just to go straight to Mars. There's no reason to go to the moon first. And obviously with in situ resource utilization on Mars, there's no reason to mine water on the moon because water is much more plentiful and easy to get on the Martian surface. So, Michelle, if you want to read about radiation effects on people on Mars, Case for Mars has a very extensive treatment of all of the things that have been brought up as human issues with going to Mars, whether it's radiation, whether it's people going crazy and killing each other, all that kind of stuff. Very, very treated in great amount of detail in the book, A Case for Mars. I can't recommend it highly enough. I think Case for Space is updated, so try Case for Space. It's Dr. Robert Zubrin is the author. Highly recommended. What is the level of life support required on Mars? Well, level of life support required on Mars is pretty much everything, right? You need oxygen, you need buffer gases. You can't breathe pure oxygen all the time, so you need nitrogen. You need things to create an environment that people can live in. You also need shelter, right? You need shelter from radiation because Mars doesn't have nearly as much of an atmosphere as Earth does. So you do need some radiation shielding. So you need to cover your habitations with sandbags. One of the interesting things for plants actually like CO2. So Martian atmosphere is very good for plants. Plants will actually grow better in a Martian atmosphere, which is heavily CO2, than they do on Earth because they eat CO2 basically, right? So again, Case for Mars has very, very comprehensive coverage of what we need to do for habitations on Mars. Burrowing into the ground is obviously one possibility. 3D printing habitations made out of regolith, like essentially adding water and making mud brick to build your habitations is another thing. It is certainly possible to create hydrocarbons straight from the in situ resource utilization tools that we're using on Mars to create other things. So creating hydrocarbons means you can create plastics, which means you can create plexiglass for your domes to protect them from any impacts from sand or dust, and you can also print or you can also generate plastic linings for these things to hold an atmosphere. So there's a lot you can do to create plastics, and obviously Mars has a lot of iron because the fact it's red is because the surface is primarily iron oxide, right? So there's a lot of iron, so you can easily extract that iron with very simple processes that we've used for hundreds of years. And there's lots of carbon, obviously, so in the atmosphere, so you can make steel fairly easily too. Simple materials, yes, but they can be made in situ. So I think I covered the timeline. Basically, every 2 years starting 2023 is is what you're going to end up with. Ed says, hate to ask effects on the environment. Well, these are rockets, right? But I think methane oxygen is a lot better for the environment than kerosene, which is what a lot of rockets burn is kerosene. So like a hydrocarbon, at least with, as long as you're not letting methane out into the environment, methane being a fairly bad greenhouse gas, right? So you have to be very careful about letting it out to the environment. But at the same time, I think these are relatively neutral as rockets go. I think they're better than a lot of the rockets they have now. But it's not really my area. So they're doing an environmental assessment, and that will be published at the end of February. So you're going to be able to read all about it in nauseating detail, right? GHG emissions for an Earth-to-Earth Starship drill. What's GHG?
Greenhouse gases.
Oh, okay. Again, as long as you're, if the reaction I think you get when you burn methane with oxygen is water and CO2, right? CO2 is a greenhouse gas, admittedly, but I don't think the CO2 emissions of a Starship is going to be remarkably different than what's emitted by an airplane. So it could be neutral or based on the capability. I'm sure these calculations have been done. The thing is, if you're sending a Starship on a 40-minute trip to Shanghai, if you have a route between, say, New York and Shanghai, and you're sending a plane every 2 hours, you probably have a lot of planes on that route, right? So essentially you're flying a whole bunch of planes. They're all flying for 20, 30 hours and emitting all the way. Whereas if you've got a Starship, you've got a 40-minute trip, right? The bulk of the fuel is expended at the beginning of the trip and converted into water and CO2. And it's a ballistic flight. It lands, so you're burning some fuel there. And I think, because you're only flying a few of these things instead of a whole fleet of many different planes, I actually think it should net out to less. I know that it'll be interesting to read that environmental assessment. And as I said, the propellants are methane and oxygen. So permafrost on Mars is a source of hydrogen. Yeah, if you can dig it up, if you want to dig it up, it'd be nicer to find liquid water. But if you want to dig up permafrost under the surface and melt it, there's lots of water on Mars. What if they find life in that water? That's really interesting, because Earth and Mars have been really exchanging DNA or exchanging at least rocks for many, many millions of years. So, I suspect they may find life on Mars that came from Earth, or they may find that Earth life came from Mars. There's no way. Obviously, we've got meteorites that have essentially what looked like life at one point, and experts have said that basically, life could survive. The kind of life that we have on Earth could survive even that long trip in space and a long time in space. I was reading something about that. So again, that's the case for space as well. So it's kind of the one-stop shop for this kind of stuff. But if they find life in the Martian water, great. Is it going to kill us? No, because life on Earth has evolved for millions of years to kill us. Like, I don't think life on Mars would be terribly good at killing us, right? So we'd kill it quicker.
I just had it's just kind of funny, because when we send probes to Mars, we make sure they're sterile and everything. And I'm watching this video and says, okay, let's dig up some boulders, throw some rocks around, make some fuel, and then go. All of a sudden, you're also being destructive. So if there is life there, it's almost like you don't care until you have the infrastructure in place. It's just kind of a weird thing. I'm all for Mars, but that's why I brought it up.
So you're saying that, you know, it would be ethically challenging to find life in Martian water and kill it by refining it into rocket fuel.
Yeah, that you need to get off the planet.
Well, you're sending hydrogen, so you don't need water to start with.
Yeah,
So
it just seemed kind of destructive in that regard. I mean,
sure, you're mining stuff.
yeah.
Yeah. So who's going to find water though? Or who's going to find life? Probably somebody who's standing there looking at the water under a microscope, right? So that's an ethical thing that will have to be dealt with. But the initial exploratory flights where people will be coming to look for life will be bringing their own hydrogen. So I don't think it's nearly as much of an issue, right? And yes, it does sound like the Expanse, except the Expanse has a magic rocket that doesn't need as much fuel as real rockets do. So, yeah, I agree, Christopher. The related benefit to becoming a multiplanetary species is the change in perspective that would result from it, definitely. Yeah, we just actually, SpaceX lost 40 Starlink satellites to the great amusement of a lot of people because when they're first launched, they actually are launched at a fairly low orbit. And that's intentional because if they fail, they want them to re-enter quickly. So they want to make sure that they're actually working before they boost them into a higher orbit, so they don't risk having a non-functional satellite in an orbit where it's not going to deorbit ever or quickly. So the reason they lost 40 of them is the solar activity caused the atmosphere to heat up. It expanded, and it expanded beyond where these satellites were, and they experienced enough drag to drag them into the atmosphere and destroy them. So yeah, that it's unfortunate, but it's SpaceX is actually very good stewards from a lot of perspectives. Like all of they deorbit, if it's possible to deorbit their second stages, they do. They actually reserve fuel in their second stages on their current rockets, the kerosene rockets, the Falcon 9s that they send up satellites. There's a booster stage, and then there's a second stage, and then the satellite sits on top of the second stage and is boosted into orbit. Those second stages, generally, they reserve enough fuel to deorbit those second stages if they aren't going to deorbit themselves. So that's very, to me, that's much more responsible than a lot of the government flights. Obviously, Chinese and Russian people destroying satellites in orbit is a really stupid thing to do from a Kessler, cascade kind of thing. But I don't think these traditional space programs pay enough attention to keeping things clean. So we need to send starships up there to hoover it all up, and hopefully, if it's cheap, the government will hire them to do that. So you sent me a link, Case for Mars. That's it. Yep, the bright red cover. Robert Zubrin. Look for Case for Space by the same author, because I think that's the same book, except it's been slightly updated, and it incorporates a lot of this SpaceX stuff. So yeah, and Chris DeRoche said if SpaceX even a few years off the timeline to getting there, that would be, he'd be very happy. I'd be very happy, even if they're a couple of years off. The worst case scenario is the government says, okay, we don't like your environmental assessment. You have to do a much more complicated environmental assessment. Actually, Musk was asked this last night at his presentation, and he said, well, you know what, we'll just build in the Cape. So they'll go to the, Cape Canaveral, Cape Kennedy, whatever it's called, the Kennedy Space Center. And on pad 39A, they'll build another Mechazilla, and they'll launch from there, because obviously they've already begun an environmental assessment there. I think politics might intrude there too, because I'm pretty sure Texas politicians will not want SpaceX going to Florida. So that may work to SpaceX's benefit. So needed for Mars, Jay. Water, food, dances, music, love, friends, asparagus, flushing toilets, art, Swiffers. hey, with 100 tons of cargo room, you can send all that stuff. Really interesting, actually. The one lunar mission that is interesting is it's called Dear Moon. It's a Japanese billionaire has hired a starship, and he's going to put a whole bunch of artists on the starship, shoot it off into an orbit around the moon. They're going to go off and orbit the moon for a week or two, come back, and you're going to have a whole bunch of artists and artsy people who have been to space and been to the moon, and they'll be able to tell us all about it in their own intimate ways. I didn't say that right, but whatever. Great, that looks like all of them. Send Sylvia. Yeah, I think you could actually submit your name. Google Dear Moon. I'm sure it's not open anymore, but at one point you could submit your name. So is that it for questions? Going, gone. Thank you so much for spending the time to view this presentation, and I'm happy I finally got to do it because now I can stop working on it. So thanks, everybody.
Thank you very much, Gord. And that concludes our meeting for tonight. But everyone's welcome to stay on, and we have a virtual get-together, Boston Pizza. And I hope you all have a great evening. I'm going to have to make another phone call at this time, but you all have a great evening, and thanks for coming tonight. Good night.